All right, 10 o'clock on a Thursday. Everybody ready to get going? Cool. Victoria, how's the sound level? Morning, Lloyd. Awesome. Perfect. So, I asked you on Monday morning how week 2 was going. Is the answer any different? What do you think? Learning lots this week? Is it just review? Like, what is it for everybody? So much information. Awesome. What'd you think of TCP yesterday?
What is that?
Fair enough. So, yes, did that challenge your ideas of how you thought the internet worked? Or did you have any preconceived notions about how the internet works?
I thought it existed.
Yes.
Nobody made it.
It was just there. Okay. So for Victoria, the Vancouver students are telling me that they thought the internet was just there. It just existed, and nobody was responsible for it. Did you find out who was responsible for it?
Everybody.
Did the lecturer get into the history of the internet or anything? No. Okay. That'll be something you'll have to research then, if you're so inclined. Cool. What about SNEC? You like that? Was that fun? Victoria, did you do SNEC as well? I'm assuming you have a Raspberry Pi there. Was that everybody's first experience with a Raspberry Pi? Pretty much. Did anyone realize they were even interacting with a Raspberry Pi? Cool. Split answers. Awesome. Yeah, they didn't do that when I was a student here, so I'm excited to see some new stuff in the curriculum. Cool. So today, we're going to introduce something new yet again. We're going to introduce the concept of promises. But unlike this time last week when I was talking to you about callbacks, and I said, my goal is by noon, everyone is going to understand callbacks. Not so with promises. Think about this as more like an introduction. I'm going to kind of show you the solution that promises afford us as developers and a kind of different way of thinking about async flow in your programming. But you're going to get lots and lots of opportunity throughout the curriculum to use promises and consume them. Okay, so we're just going to kind of touch on it briefly today, and we'll take a look at them. But I don't expect you by noon to say, I know exactly what a promise is. I'm set. I can answer any job interview question around them. Okay? So we have our to-dos. Oh, Victoria didn't have one. Oops, we interacted with someone's phone hotspot. Hey, that's pretty good. Solutions. I always like to think that programmers are first and foremost problem solvers. So when we encounter something unexpected, we know how to solve it, right? Okay, cool. So today, our to-dos are, we're going to sequence asynchronous tasks. So in other words, ones that depend on the previous ones, without going into this so-called callback waterfall. And we'll demonstrate that callback waterfall just to really hammer home what that is and why it's an issue. Then we're going to introduce promises as an alternative solution. We'll get into error handling. Then we're going to do something that we can't really do with callbacks, which is parallelizing. Running things in parallel. Okay? And then we're going to start creating our own promises, which is going to be a lot of fun. Okay, so first things first, let's get into callback heck. Okay, we used to have a mentor here who would always look at people's code and say, "That's not callback hell. That's not even callback heck." You will experience callback hell during your midterms. I can almost guarantee it. Okay. But we're just gonna demonstrate some callback heck here. So let's say that we have a function. How's the font size? Is it good in the back? Do you want it one higher? You okay? Okay. So let's say we have our first callback. We're going to call this callback 1. Let's say it's a higher order function. So it accepts. Let's go with an inline anonymous function. Are we okay with this? We've got a higher order function that accepts a callback. Okay? So far, so good? Okay. So let's assume that when it resolves, we get some data back, and we'll call this data 1. And we need that data 1 to feed something else. Maybe we're getting like a user ID from one area, and then we need to fetch the user from somewhere else, and then maybe we need to fetch their blog post from somewhere else, or their profile image. But we need to do all of these things in order. So if we depend on the data that comes back, where do we need to put our next step in the process? Can we put it down here? Can we say callback 2 down here? No. Where do we need to put it? That's right. We need to put it inside of callback 1. If we depend on this, we have to say when this callback fires is when we have access to this data. We don't have access to it anywhere else, right? This should just be a review. So in here, let's say we've got callback 2, and it also accepts a callback. And then in here, we've got callback 3, and we just keep passing this data along. Let's say we're doing more operations. I'm just trying to keep it bare bones for simplicity's purpose. 4, there we go. Data 4. All right. Here we have and then finally, once we have all of our information, maybe we do something. Maybe our web server returns a JSON object to the client. Maybe we output something to the console, okay? But we end up with something that looks like this. And here's kind of the hallmark of callback heck. If you ever see these in your code, and this is one of the reasons, remember we talked about how, and you watched me as I typed it out there, I like to make sure that everything's closed as I'm typing, right? Because you don't want to have to get into the, is it one? Why is that not right? Is it one of these? You've probably encountered that already, right? Where you've got something, you're missing a closing curly brace or something at the end, right? Okay, so this is our current solution. If we don't learn any other way, this is just what we have to do. This is just a necessary evil, okay? And you will get into this. There's nothing necessarily wrong about this. It's just not very readable. Ultimately, at the bottom of this chain, we have access to all of this data, right? Because we are inside of the scope of all of those functions. So if I called something like data 2 in here, we would have access to that from further up, because technically this is one callback, okay? Even though it's calling a callback inside of that and a callback inside of that, it's like those nesting dolls, right? So we end up with this kind of concentric rings, if you will. And the deeper we go, the more levels we go, the more we're going to end up going across the screen. And right now my tab is only 2, but if my tab was 4, then we'd end up with there, and there, and there. And you see how it can just end up going all the way across your screen, except I guess from your perspective, it would be that way. So how is this for review? Does that mesh with what we know so far? Any questions about this? Can you think of an example of where you encountered this kind of thing? Perhaps in the curriculum, perhaps 2 days ago. Yes. Sorry? Yes, exactly. The profile generator. Fantastic. Where's my Chrome? Let's log into Compass. There we go. On day 2, eventually, here we go. Day 2. Come on. Day 2. Week 2, day 2. There we go. Where are we? Fun profile generator. Awesome. Loading. Okay, so we ended up with this. Essentially, we started from here, right? What do you think of Node? And then we ended up asking a whole bunch of other questions, like what's your name? What activity do you like doing? And ultimately built out a user's profile for some online social media service, right? Okay, so the good news is I spent some time last night and created my own. Oh, before we get into it, let's consume it, because I want to kind of illustrate a point that we talked about either Monday or last week. I think it was last week, about the concept of abstraction. This is the main thing that we do as programmers. We abstract away complex logic into little consumable things that other people can use without even caring about the implementation. And I want to literally demonstrate that for you right now. So if we look at this, we have survey.js, which is my callback solution for the survey problem. And then I've also written one using promises. And we're going to consume them right now. So let's make the font size a little bigger. Any questions? Nope. Okay. Node survey.js. What do you think of Node.js? Well, I think it's awesome. What's your name? Andy. My favorite activity, let's go with bowling. What do I like to listen to? How about some grunge music? What's your favorite meal? Breakfast. And what's your favorite thing to eat? How about some oatmeal? There we go. So we got, hi, my name is Andy, and I really like bowling. I listen to grunge while eating oatmeal during breakfast, and I think Node is awesome. This is one of my favorite. It's like Mad Libs. This is great. Okay, so does this look familiar to everybody? I didn't ask as many questions as you were asked to implement. I just wanted to get to the point where we experience callback hell. Okay, now let's do the same thing with promises. What do you think of Node? Well, it's kind of boring. What's your name? Still the same. Favorite activity? Let's go with coding. What do I listen to? Well, heavy metal, of course. And what meal is your favorite? Can we go with dinner? And let's go with chicken nuggets. There we go. My name is Andy, and I really like coding. I listen to heavy metal while eating chicken nuggets during dinner, and I think Node is boring. 2 exclamation marks. Okay, so do you notice any difference? No. Excellent answer. Perfect. Remember what I said? I don't like to ask trick questions, so there won't be any trick questions. But from a consumption perspective, what's the difference between running node survey.js, and it asks a bunch of questions and produces a profile, and node survey promise.js, which asks a bunch of questions and produces a profile? From my perspective as a client, as a consumer, what's the difference? There is none. It's just a different file name. And I want to show you that this is abstraction absolutely demonstrated, where you do not care at all about the implementation. You know that when you run this program, it's going to ask a series of questions, take your answers, and generate a profile from that, right? Beyond that, you do not care. When you call array.forEach and you iterate over each of the elements, do you really care how JavaScript implements that in the background? No. It's just something that you're supposed to consume, right? So I really want to kind of hammer this point home that we build abstractions. This is what we do, and it's not as important, and we talked about this while testing, it's not as important how it's implemented. It's important that the functionality is there, that the tests pass, that the user can do what we told them they could do with it, okay? So now let's take a look at some code. And normally I would live code this for you, but this is a lot of code, so I just pre-typed it. I hope that's okay. Okay, so if you don't recall, we had to bring in the Node package. We talked on Monday how Node has a bunch of different packages that we can bring in, right, that are part of the Node thing that allow us to do various different things. So we bring in the readline library, and we set it up, and we say our input is going to be standard in, and our output's going to be standard out. This should just be a review from Tuesday. So this is my particular implementation. I chose to have an answers array that I could just push all the answers into. Okay? So then we get into readline question 1. What do you think of Node.js? And then when the answer comes in, the callback fires, right? And we get the answer. So we'll push that into our answers object, or our answers array. Then next question. See, each one is dependent on the one previously, right? We can't just ask all the questions at once, or we'll have no idea how to attach those answers to any of these questions, right? Okay, so next up, what's your name? Again, push the answer in. What's your favorite activity? Push the answer in. And you see how we're starting to build out to the right. And this is all inside of one massive callback. And then inside of that, a smaller callback, and inside of that, a smaller callback, until we get down to the final answer that gets pushed in. Okay? Then I call read line close, so it doesn't just sit there hanging and waiting for some kind of answer. Then I use one of my favorite things here, which is ES6 destructuring. And this is array destructuring. And I like this so much more than object destructuring. So what essentially this does, if this isn't familiar to you, is, has anyone seen this before? ES6 array destructuring? Okay, so imagine that we had so the very first question was, what do you think of node? So that was the first thing that was pushed into our empty answer array, right? So this is the answer to what do you think of node would be at array position 0, right? So we could say, if we commented this out, we could say node equals answers at 0, right? And then we could say, well, the next question was, what's your name? So that would be answers at 1. So instead of having to do this in several separate steps, ES6 allows us to name our variables. What we're saying is, whatever's in the 0th index, I want you to pull that out and store it in a variable called node. Whatever's in the first index, the 1th index, pull that out and store it in name and activity and things like that. So it is equivalent to doing this, just all in one line, okay? And that's why I love it. It's nice and precise, and we can handle all of our things, and we don't have to use square bracket syntax. Yes?
Are the names for the initial array, like node, name, activity, are those necessary or used at all, or can they be anything to whatever
In this destructuring array? Oh, we are actually, so we're saying take this array and break it out into 6 different variables called node, name, activity. Does that kind of, so this is a name that I've given it so that I can use it later. So this is, like I said, this is the equivalent of const node equals answers at the 0th index. Okay? So these are names that I gave it. Yes?
So if there was one more variable that you wanted to pass or put a name on,
Mm-hmm.
you didn't declare it, would it just exclude that from
Yes.
that array?
So just like, so I want you to also, I realize this might be a little confusing. I probably should have done it the other way. We're not actually creating array here. This is array destructuring, the same way that, let's say I have a user object, and I want to get the username out of it. So I would say const username equals user, right? So let's say this is a user object with a username property. So this is equivalent to, so that's object destructuring. This is equivalent to that, right? Pulling a property off of an object. We're saying const username equals user.username. But we can use destructuring to say I want that piece of it off of the user object. Okay? So this is not creating a new object, right? This is creating a variable called username that we can then consume later. We can say, oh, hello username or whatever like that, right? So this does not actually create an array. This is array destructuring. Okay, the same way this does not create a new object with a key called username. Does that track for everybody? Maybe if I put them side by side. Destructuring, yeah. So these two lines are equivalent. Does that make sense to everybody? So all we're doing here is saying, I want you to create a new variable called username, and I want you to store whatever's in the user object at username in it. Yes?
And can you rename it like you did with the array?
You can actually. You could do something like that, and then you could make reference to it later. That's not as common to rename them, but you can put a colon in there and alias it if you want to.
And then is it the same like syntax to add more, like with a comma and then
Yes. Yeah, absolutely. So you would just, if you had like age, something like that, and you pull all of these off. Okay? Did you have a question? Say. Yes, yeah, absolutely. You can pull whatever you want out of here. Maybe there's like a friends array that's in there in the user object as well. You could pull all of these out. Okay. So this is just some quick destructuring so we can do it all in one line. Okay. Then I do console log just to give us some separation. We saw that in the output, just to give a little separation between the questions. And then we do our Mad Libs game. My name is name, and I really like activity. I listen to music while eating food during meal, and I think node is node. I think I could have just left it like this. I think that sounds like a fantastic profile. I would want to be friends with that person. I like activity. Okay, so does this look kind of like what you implemented on Tuesday? And you'll notice, remember we said the hallmark of callbacks is you see this step, this ladder down the bottom of all of the callbacks closing and each one closing out. So I was thinking about how I wanted to demonstrate promises to you. And I've seen so many YouTube lectures and Udemy courses and stuff like that where they demonstrate things to you with completely useless applications. And I really hate that. It kind of irritates me because you're trying to understand something while they're also just kind of demonstrating some other thing to you. So what if we redid this entire thing? Spoilers, we've already ran it. Redid this entire thing using promises instead. So I looked up, and it turns out that there is an NPM package called readline promise. NPM readline promise. Hey, hey. There we go. So a drop-in replacement for readline with additional promise-based methods. Okay? So, and we can see that it was downloaded 6,300 times this week. We could go through to the GitHub repo if we wanted. But we can see that if we want to bring this in, they use var, but all we have to do is say var readline equals require readline promise.default. And then we can start using it. You'll notice that this readline.create interface sounds a lot like, where are we? Readline.create interface, right? So it essentially just maps right over the functionality of readline, but instead of using callbacks, it just uses promises instead. Okay? So let's say that I've already written this all out. Let's jump into survey promise. So here we go. Just like it said in the instructions, we're bringing in readline, require readline promise.default. Set it up, same as before, input, output. Here's our answers array. And then here's where we start dipping in to promises. And we'll talk about the syntax in a little bit, but I just wanted to give you a preview of what promises allow us to do. And if you'll notice, there's none of that callback heck that was going on in the previous file. Yet the output is exactly the same. So for comparison, step, 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 all the way down, versus promises, everything is nice and in line down the left-hand side. Okay? And as we already saw, the output is exactly the same. A question gets asked, an answer gets pushed into the answers object, a new question is asked, that answer is pushed, and once we're finally done, we close off the readline process, destructure all of our answers, and console log our user profile. Okay? So before we dive too much more into this, let's talk about promises. So in real life, what is a promise? What does a promise represent to you? It could be considered a contract. Could you elaborate on it's a contract?
Somebody says they'll do something for somebody else, and the other person says, I agree. Yes.
Somebody else. And presumably, the other person agrees. And then it presumably, what is the ultimate outcome? If I promise to help you move in exchange for pizza or something, but let's say I promise to help you move, what are the two options that will show that you're moving on Friday? You said, okay, Andy, meet me at 10. That's when the moving truck gets here. What are the two options at 10 a.m. on Friday? I'll be there or I won't. Either the promise is fulfilled or the promise fails, right? Either I show up or I don't. Those are your two options, right? What about on Thursday? You called me up and you said, okay, moving truck's going to be there at 10 a.m. on Friday. What situation is our promise in at that point? Limbo. It is in, the promise is in limbo until it is fulfilled or it fails, right? Because it's just, what is a promise until you actually do something about it? I promise I'll get you coffee, and then you're sitting there waiting. You don't know whether to condemn me or congratulate me until either the coffee arrives or you go till lunch with no coffee, right? So we have the same kind of concept in programming. So instead of attaching a callback to something that's asynchronous, so we're saying when this thing resolves, when whatever happens, when you get the records back from the database, when you hit that API, when the user types in their answer, when our web server gets a request, run this callback. That's how we've been handling this, right? So we're deferring that to a future time. Does that make sense? Okay. Question? Something that should happen sometime in the future. Yes, exactly. That's a good example of a promise. So instead, in JavaScript, a promise is actually an object that gets returned immediately from a function, okay? So instead of saying, I'm going to register this callback, you run the function, and it immediately gives you back this object. It immediately gives you back this promise object. And so can you think of any reasons why this might be advantageous to us? To immediately get back something when we say, this is a function, it's attached, it's tied to this event in some way, this procedure, but instead of registering a callback that's going to run at some point, we get back an object immediately. So what does that give us the ability to do? Write something that possibly looks more like synchronous code? Yes. What else could we do with this? What can we do with a object versus not having anything tangible at all that we can hang on to? We could look up things in the object. We could check out, say, the promise's status. Like, where is it? Is it still in limbo? Has it been fulfilled? Did it fail somehow? We can, since objects are values, we could push them all into an array. We could pass them around. We could move them between objects. We could pass them as arguments to a function, right? So it frees us up a bit in how we want to structure our asynchronous code, okay? So as we kind of touched on, a promise will be guaranteed to be in one of three states. And officially, these states are pending, which means the promise is still in limbo, right? Neither fulfilled nor, as we'll talk about, rejected. Spoiler, the next one is fulfilled. The promise has resolved. Whatever action that you were taking, retrieving a user, making an API request, something like that, this is the moment when your callback would fire if you were passing a callback, right? Or they like the term rejected. The promise has failed in some way. I didn't show up to help you move. I didn't ever return with that coffee. The coffee maker was down, something like that, okay? Something happened during our operation and it has failed. These are your three possible states for a promise. Bless you. So is that pretty clear? We're pending up until we either succeed or fail. Okay? That's the moment when we go from pending to not pending. And there's no way to go back. A promise either succeeds or fails. You can't go back again. If you yell at me that I didn't bring you coffee, the only thing I can do is promise you that I'll do it again, or promise that it won't happen again, that I'll do better next time, right? There's no go backsies. I can't say, hang on, let's rewind time, okay? So pending, and then either fulfilled or rejected, okay? So interestingly, promises utilize callbacks. Just in a slightly different way. But as we go through the survey promise code, you'll see that we're actually just writing callbacks. Okay? Oftentimes, promises and callbacks are kind of conflated. You say, well, anywhere that I use a callback, I can now use a promise because I know what promises are. Or anywhere that returns a promise, maybe I can sub in a callback. Okay? Think about it more like a different tool that can accomplish a task rather than a straight up replacement, or that the two tools can't work together, okay? A lot of what we do, again, as programmers, just like choosing NPM packages that we want to install, is about choosing the right tool for the job. In some cases, a callback is perfect. Like you're gonna run a for each loop. Well, it's already set up to use callbacks. Why would we rewrite that entire thing to use promises? It takes a callback, we'll use a callback. Express servers, as we'll get to, use callbacks to answer routes. Why would we do something different? But if a library returns a promise, then we should know how to consume that as well as an alternative. So usually you won't be making your own promises. They'll come from an external library. Async library. Okay? Because that's generally why we use promises, is purely to handle asynchronous operations. Okay? So, how do we let the promise know? Let's say I've got my promise all wrapped up. Here's my new promise right here. Let's put this into JavaScript so we can get some syntax highlighting. Okay, so let's say I've got some const new promise equals function that returns promise. Okay, so let's just say, for interest's sake, that this function here, the return value from that is a promise, and I'm going to store it in a variable. So what do we know immediately about this based on what I said here? You get an object that returns immediately, okay? That's what we're storing into here, is actually our promise object, okay? And then how do we get the information back out of that? Well, you call, actually, .then on it. All this is a method on the promise object that we've wrapped up in here, and we have a .then that says, then, so we have a promise, then when it resolves, do this, okay? And it's a method, like I said, and guess what it takes as an argument? A callback. So let's say this function returns a list of users or something. Well, then we'd have access to our users right here, and we could console log the data. And that's it. All we have to do is just chain on a .then. And we can wait for that promise to resolve. But we can see how this kind of makes it a little nicer to run down the side rather than running into callback hack, right? Okay, so McDonald's receipt. Thank you. Here we go. Hopefully I can find a good one. There we go. This one is absolutely perfect. Okay. We had a lecturer here that came up with the idea of the McDonald's receipt as our callback example. All we have at our disposal are analogies. And as KV will point out, an analogy is imperfect because it's an analogy. If I was describing the actual thing, I wouldn't say this is an analogy, right? You'll be watching, is anyone familiar with Fun Function? MPJ? Yeah, fantastic, right? You'll be watching a video later today where he talks about promises, and he uses mortgages to explain promises. That you could go to the bank and you can say, here's how much money I make, here's my credit score, how much can I borrow? And they'll say X number of dollars. And then you can actually take that and go around and start making offers on properties, right? You don't actually have that money, but the bank has kind of promised that they'll give you that money. So you can start negotiating with sellers to buy a property, right? But you don't actually have that money, and anything could happen. Maybe there was something that you neglected to mention about your credit score. Maybe you lose your job, something like that, and all of a sudden your mortgage falls through and your house offer falls through, right? Or everything goes great, you place an offer on a house, mortgage goes through, you get the money from the bank, and you buy the house, right? So that's his kind of way of explaining it, and he probably does a much more entertaining job, and he has much better hair. All right. This is one that I really like. Is everyone familiar with the new McDonald's ordering system, where you no longer stand at the till and wait for your food to come back? Okay. What happens? Okay, so for anyone who's not aware or doesn't frequent McDonald's daily like I do, they have moved away from the old system where you go up to the counter and you place your order with the cashier, and then they fulfill your order right in front of you. They would go grab, the things out of the warming tray, bring you back a Big Mac and a fries and a Coke, and put them on a tray and give it to you. And then they help the next one in line. That's a very synchronous operation, right? So they've decided to go async. They've decided to decouple the cashiers from the customers that they're serving and the particular orders. So now the cashiers or the interactive terminals just take your order. They take it, they send it to the kitchen, and they give you back an order number. And then you stand in line like you're at ICBC and you wait for them to call your number. And when they call your number, your food is ready. So they have one distribution point. And they call 165, and then you go up and you get your soft serve cone and your hot apple pie and your small coffee frappuccino. Oh, I'm too hungry. Okay. So does that answer your question? So everyone's on it. There's one like a block away. I should take everybody for lunch that we can experiment with this. Okay, so you walk up to the counter and you place your order with the cashier, or you go to the interactive terminal and you place your order, and then you pay. What do you get back? And this is kind of spoiler because it's on the screen. But what do you get back from the cashier? What do you get printed out at the terminal? Yes, you get an order number. And what is this order number? It's a promise. Exactly. It's a promise that they will fulfill, that at some point in the future, you're going to get a soft serve cone and a hot apple pie and a frappuccino. Right? But you can't just take it up to the counter and say, I want this back now. That's an asynchronous operation. It's going to take some time to prepare this frappuccino. Some indiscernible amount of time. Right? But this is your promise that they will fulfill it for you. If you stand there waiting for 20 minutes and nothing happens, you can go up and say, look, I've got a receipt. What happened here? You promised that you would give me this food, right? I paid you in good faith. So this is kind of our promise. We can exchange this at some point in the future for real things. But until that happens, this is pending. Does that help kind of explain what promises are? That's one of my favorite analogies. I like food analogies. Everybody eats. I think that's why I like it. It's kind of the universal. Cool. So there's a real life example of a promise. How are we doing for time? Awesome. Okay, so we were in here and we had arrived at, we can call .then for when our food is ready. This is, if this was our McDonald's order here, this is our receipt. It's our new promise, and we call .then, and we get our food back. And then we can consume the food, right? We consume our data. We do something with it. The operation has finished running, and now we have access to whatever our data was, whatever we were trying to get, okay? So let's take a look at survey promise again, okay? Scroll down a little bit. Now, something to note is that by default, as you can imagine, a library called readline promise, it returns a promise. So when we ask rlp.questionAsync, so asynchronous question, you'll notice that before we were asking rl.question, right? The only reason for the P here is just to differentiate because it's readline with a promise, okay? Other than that, syntax is essentially the same. We're saying asynchronously ask a question of the user. Put into standard out, what do you think of Node? And then wait until the promise gets resolved. So we call .then. We say, hey, you gave an answer back. Great. I'm going to store that answer. One of the awesome things about promises is we have this concept of a promise chain. If a function returns a promise, we can just keep putting it onto our chain and keep stringing them along with a series of .thens. So we store that, and then we return. This is important. You want to return the next promise in line, and we create a whole new promise. RLP question async, what's your name? So this, the return value from this, is another promise. So what can we do with that? We can call .then on it and get another answer and do the same thing. Push it in and return another promise and call .then on that and move our way all the way down. As long as we're still returning promises, we can still keep calling .then on everything until we get down to the bottom where we run out of promises. We've used our last promise. This is our promise chain, .then, all the way down. And we're finally ready to do something with all of our data. Okay? But unlike in survey, where we did the same kind of thing, but all with callbacks, everything had to be inside of the previous callback, all the way down, right? Inside. And this becomes a little, like, if you look at this, does that code make a lot of sense? Is it easily readable? You could argue that this is not very complex, but it's not very readable, is it? It doesn't really flow very well. Whereas, what do you think of this code? Beautiful. I like that. Elegant. Simpler, for sure. So this is a nice solution to this kind of problem. We just keep calling .then all the way down. Okay? And as we already saw from the outside of the program, everything runs exactly the same. As far as the user is concerned, these two are identical. Right? So it's a nice solution for us here. Okay, so are there any questions about, this is absolutely the most basic use of a promise, which is essentially a glorified callback. Okay? We've just moved the callback from passing it as an argument to calling .then and then passing it as an argument. Okay? We haven't really done much more than that. We haven't gotten into the passing the objects around or putting them into an array or calling them in parallel or anything like that. This is the simplest way to consume a promise. Okay? So you might be asking, well, promises, that sounds all well and good, but can we actually use them? So if we want to find out if we can use something, we go to MDN, and we do a search for promises. So here we're talking about the promise. And then I like to scroll. So this will tell you all about promises, and there's a nice drawing here of like the events that it goes through. We can look at that. So it sits as pending as a promise. Can everybody see that? It sits as pending, and then it can either be fulfilled or rejected when you call .then, or you call, as we'll deal with later, .catch. If there's been an error, we can catch the error. And then if it returns, we can return another promise and then move down the chain with another .then, .catch, and we continue on down the chain. But anyway, that's not why we came here. Enough with the pretty pictures. You can scroll all the way to the bottom, and this will actually tell you, if you get into an argument with somebody, when did ECMAScript introduce promises or some other thing? You can look it up on MDN, and you can scroll all the way down, and you'll see that it was added on ECMAScript 2015, 6th edition. 6th addition, what we refer to as ES6. Okay? So from 2015 onwards, we've had native promise support in JavaScript. We can create new promises and we can consume promises without having to bring in other libraries. Prior to 2015, we had to bring in libraries like you may have come across Bluebird. Bluebird is a promise library. They had to write their own promises, and you had to bring this library in if you wanted to consume promises prior to 2015, or some other promise library. Nowadays, we can handle promises natively. As you've seen, the reason why I had to bring in this library here was just to give me back a promise, just easy promise creation. I didn't bring it in because it has special things about it. We're doing native promise resolution here with the .thens, okay? But yeah, this is super handy for checking how long something's been around, okay? And if you scroll down a little more, you can see which browsers. Has anyone ever taken a look at this at the bottom of MDN? Awesome. So you can see which browsers support it and which ones don't. And of course, in Internet Explorer, no native promises. But where's Edge? There's Edge. Much better now. They support promises now. Okay, so how are we doing for time? 10:47. Let's quickly look at error handling. If we scroll up to the top, we had an introduction to promises. Let's look at error handling with promises. Okay, so new category, error handling. Any questions so far? Feel free to, yes.
This is a general question. In other languages like Python or C or C++, I don't know about C, but you have the user input is very easy to reduce, whereas in JavaScript it's much more complicated to get sort of user input through node.
Right.
Why is that? Or why isn't there just a simple input user data sort of function?
Okay, so for Victoria, I'm going to paraphrase. And I see that, Caitlin, I'll do that shortly. I'll paraphrase. In other programming languages, simple operations like reading from standard in are kind of intuitive or easier.
Yes.
But in JavaScript, not so much. And why is that? It has to do with the choices that were made when the library or the language was created. You had the creators of it did certain things to, we're going to solve this problem in this way, and that means we have trade-offs that we won't be able to do that in this way as well. The other thing is because, as we talked about on Monday, JavaScript was created for the browser. It was not created to run a web server. So a lot of the things that we have access to, like the event loop, as you've probably read about. Have you seen the JavaScript event loop? JavaScript event loop. There we go. Images. There's a pretty good one here. Here we go. So we have this concept of the event loop, and this comes from the browser. So we've always had this kind of asynchronous thing. Like, you've got a button on a web page, but you don't know when the user's going to click on that. You don't know when they're going to click on a link. You don't know when they're going to try and sign in. So we have this event loop that's constantly running and just listening for things to happen. And if something happens, then it puts it onto the queue of things that need to be run. So somebody clicks on a button. OK, the next time through, we're going to process that. OK, somebody tried to log in. Next time through, we're going to process that. So this is the event loop that we are dealing with in Node as well. Because we didn't reinvent the wheel. We just took JavaScript and put it on a web server. So we still have this concept of how do we deal with asynchronous things? Well, we pass a callback. And the callback will wait until something happens, and then it will be put onto the queue to be processed. Okay? Did that kind of answer your question? That was never really written for I/O. So that might explain why it's not super intuitive to have I/O.
Trade-offs is what I got.
OK, perfect. There we go. If nothing else, trade-offs. Caitlin asked, can you please show the bottom of the survey promise document? So I can only assume that is this one. And we scroll all the way down to here. And I know it's a little bit garbled. Maybe I can, there's our destructuring. And then this is just our final promise. Okay, awesome. So we'll save that. Okay, so how are we looking? 10:50. Let's briefly dive into how callbacks handle errors, and then after the break, we'll get into how promises handle errors. Okay. So again, let's just do a little bit of a code example. So you've probably come across the fact that the node standard is error first callbacks. Are you familiar with that? So we've got callback 1. Let's say this is our higher order function, and it's going to take a callback, but it's actually going to pass the error first. So if something happened, then the error will be the first argument. Otherwise, it will pass null. So inside of this function, it would do something like it takes your callback and it says, was there an error? No, there was nothing, so pass along the data. Or, yes, absolutely, there was an error. Call the callback with the error. Okay? So that's what's happening behind the scenes. So we need to write code that waits. We can't just say, this is our data right here, like we did further up, where this is just our data and we're going to continue along. We have to have a way of knowing whether it succeeded or failed, right? So with a callback, we have this error first logic. So we'd have to say something like, if there's an error, then throw error. This is terrible error handling, but you could log it, you could have an online reporter, you could do all kinds of different stuff. For right now, we're just going to throw it, just to have the simplest thing possible. Okay, then we move into our next callback, callback 2. Well, it conforms to the node standard, so now we've got another error object. Possibly. Oh, I scrolled all the way up. Sorry about that. Okay, so that takes a callback. And it's error first, right? So we're going to need to copy this error handling and put it down into there. Tab that in, and then we call callback 3. And it is another error first callback. And again, we have to put in our, if there's an error, throw the error, and then callback 4. And we have quickly moved off of the screen, but we've also done something else. And then finally, we get down here, and we're going to do something. Okay? So we end up with code. Just for right now, I'm just going to zoom out so you can see kind of the structure of it. We still have these steps. This is our callback thing. But what are we doing every single time in here? Yes. Well, we're handling the error. We're checking for an error. But we're doing essentially the exact same thing. Imagine we pulled this out and we put this into a function called error handler that took in an error, something like that, and then did something with it. Well, that's great. We could make this code a little smaller, but we're still having to put it inside of every single callback. Every single callback has to be prepared to handle an error should it come up, right? And then we end up with even more code. And this violates one of our, sometimes this is unavoidable, but it violates the acronym DRY. Can anybody tell me what DRY stands for? Don't repeat yourself. Perfect. Don't repeat yourself. And it is the opposite of wet, which is one of my favorite things, which is write everything twice. So that usually gets a much bigger laugh. For Victoria, that was a fantastic laugh. Okay. So this is how you get lots and lots and lots of contributions to your code base. So you just copy and paste, copy and paste. But ideally, we want to try not to repeat ourselves. If we have repeating code, usually there's a way that we can refactor it to minimize the code repetition as much as possible, right? Because there is a comment. Oh, yes, showing the promise, showing the bottom of the survey promise screen? Yeah. Yeah, we looked at that one. Thank you. So we want to try to avoid this as much as possible. And promises give us a fantastic solution for this that's nice and great, and we're staying dry, and we're not writing everything twice. And I'll let you stew on that for 10 minutes. Thanks. All right. Victoria, are we back? Is everybody back in Vancouver, pretty much? Awesome. So, how are we doing? Are you bored out of your minds? Are you excited to learn this new powerful technology? It adds something more onto the stack of things that you kind of just barely understand? Cool. Awesome. Fantastic. Okay, so let's take a look at our to-dos. Hopefully we're doing a little bit better than Monday. I've been trying not to run into tangents too much. Sequencing of async tasks without the callback waterfall. So we demonstrated the callback waterfall, right? And I think that everyone, whether you fully understand callbacks or kind of partially understand promises, you can kind of agree that nice lined up in a chain, easier to read, easier to kind of reason about perhaps. So we introduced promises, and now we've moved on to error handling. So before the break, this is a review from 10 minutes ago. We were ending up having to repeat ourselves over and over and over, right? To handle errors in our callbacks. So the promises, I'll just put this here. Promises give us a great way to handle errors without repeating our code. We do this, scroll up a bit, we do this with .catch. So if .then is what we call when something is going to resolve. Remember we said we had the 3 states, we have the pending, but we're only pretty much interested in when it's, where is scrolling, where are we? Right there. When it's fulfilled or rejected, because that's when we can truly do something about it, right? So we were able to handle the state where it's fulfilled by calling .then, right? So if we want to handle the state where it's rejected, we call .catch. And you may have heard of something called a try-catch. It's the same kind of thought process of errors are thrown, so we're going to catch them. Okay, if you want to think about it like that. Errors get thrown and we catch. And it is as simple as, let's get some more example JS going here. So we've got fn that returns promise. And so we call .then on it, right? And we do something with this. So here's our callback. And inside of here, we call fn that returns another promise. And we're going to make sure that we return, right? We return from there. That way we can continue to call .then. So let's say that we have a bunch of these all chained up, and we just keep calling functions that return promises until we finally get down to our final .then, which we do something with all of the data. Okay? So all we have to do, if there's been an error at any point in this promise chain, we can write a global catcher that sits at the bottom that accepts a callback that will be passed the error in the event that something has gone wrong. And so now we can go into here and we say, handle the error. And this catch will watch all of the previous chain, everything in it. We can have all of our error handling logic in just a .catch at the end of the chain. Okay, so it's, where are we? If we zoom out a little bit. Here, we're having to rewrite the same code over and over and over and over. Down here, we just continue on trying things all the way down. And if something goes wrong, bam, we caught it. It could be this one that wrecks. It could be this one. It could be the very first one. But they will all be caught in this .catch at the bottom. Okay? So it's usually the very last thing that you'll put. You'll have your .thens, .thens, and then you'll have a .catch right at the end. Okay? Any questions about that? Can you see the advantages to I mean, we talked about one of the advantages, definitely. But can you see the advantage to just having the one dot catch at the end? Okay, cool. Any questions on error handling in promises? Or can we move on? We're good? Awesome. Victoria, as always, feel free to chime in. Okay, so now let's talk about something that we can't really do or can't do easily with callbacks, which is running operations in parallel. We want to start something running, but we want to get, let's say, a whole bunch of different things happening all at the same time. We talked about what happens if they depend on each other, in which case we have to sequence them. But what if we're just retrieving a whole bunch of information that's not really related to each other, but we want to get it all back at the same time so that we can update the user interface once? Or we need all of the different pieces to plug them together to create one console log or one file or something like that. Okay? Can you imagine a situation like that where we're grabbing disparate pieces of information from all over and assembling them together, but they're not dependent on each other? But our program is dependent on all of them coming back. So if we set them up as individual promises, we create a new promise and then we call .then. We create another promise and we call .then. We create another promise and we call .then. We actually have a really nice, simple solution for this. So let's imagine that we were able to, so we're going to call this running things, capital T, in parallel. It's 1R, 2 L's, right? Parallel? 2 R's? L's. 2 L's, 1 R. Right, perfect. That's why, this is why I do lecturing, to improve my spelling. Wow. It must be Thursday. Okay, cool. Awesome. So let's say, just for interest's sake, that we have a bunch of promises, and we're just going to call them promise 1, promise 2, promise 3. So at this point, these are the promises that we have in memory. Okay? This is the objects in a pending state. They have not been fulfilled and they have not resolved. If we wanted to resolve it, we'd call promise 1 dot then something, 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 right? But since these are all values, we can actually put them all inside of an array, right? Because they're just JavaScript objects. So just like any other objects that we'd want to put in an array, we can put all of these into an array. And then there is a helper method actually on the promise itself. Has anyone ever done something like array.isArray or something like that? So it's a method actually on the prototype, okay? And so you can do like object.keys and stuff like that, which will return an array of the keys of the object, right? Stuff like that. So promises have the same kind of things. We have the promise object itself, and it has a .all. And .all is a method that accepts some kind of iterable data structure that contains promises. Iterable is anything that we can iterate over. If that's a little confusing, arrays. Just think about arrays. We can iterate over arrays, right? We can do a for each, we can do a for of, and we can step through the array one at a time, right? So it works great with passing in arrays. So all we have to do is call promise.all and give it our promises array. And what this does, this line of code right here, I can make this a little bigger. This line of code returns a brand new promise. So imagine that we were at McDonald's and we've all placed orders, but everybody said, oh, I've got a lot of work to do, Andy. I'm just going to run back to Lighthouse. Can you take my slip and my other slip and my other slip and just wait here, and then when all the food arrives, bring it all back to Lighthouse and deliver it to everybody, because we've got work to do, right? So I've collected up all of the promises, and I can iterate through them, and I see, oh, the number's up, I've got that one, and the number's up, I've got that one. But when do I come back to Lighthouse? Do I come back to Lighthouse after every single promise and I say, here's your fries. Oh, now I got to run 2 blocks back to McDonald's to get somebody else's fries. When do I come back to Lighthouse? If you've all left me there with all of your promises. Once all of them have resolved. Exactly. So by wrapping them all together into one promise, we then just have one promise that we need to wait on. And what it will return is an array of results. And the array of results will be in the exact same order that you specified your promises in. So the result for promise 1 will be in the 0th index of the result array. The result for promise 2 will be in the 1 index. Result for promise 3 will be in index 2. Okay? So how do we resolve a promise? This should be pretty clear by now. Dot then, right? And we pass it in a callback. This particular callback will get an array of results, which we can then do something with. So just to illustrate, const result1 equals array of results at the 0th element. Okay? So once everything has resolved, then you get it all back in an array of values. These could be objects. They could be arrays themselves. They could be anything. It's whatever was returned from this promise. Could be a user object, could be database records, whatever. But we've managed to run them all in parallel. We started them all running at the same time. We said, go. But we waited till they all came back, and then we did something with them. Okay? As opposed to, if we wanted to run these one at a time, well, then we're dealing with, now I've got that information, but I don't yet have this information, so I'm still waiting on that, and then I'm waiting on this other piece. If you have things that need to be run in parallel, you can use promise.all, okay, and pass it an array. We have another one that will work for us. So this is obviously promise.all will return when all promises have resolved. One caveat to this is that if any of the promises throw, that's it. It's just going to come back. It's not going to resolve the rest of the promises. It's just going to go, oh, something went wrong. So bear that in mind, that if you have a critical operation that's prone to failure, maybe run it in its own operation with its own catch. If you need this other data and you can get by with it and this other stuff is a nice to have that's error prone, then keep that one separate. Because if you put it together with, this is like literally an all or nothing. Either you get back all of the results or you get back the first error that's gone wrong. Okay? The rest of them will not resolve. You won't have access to any of the other data. Okay? So, all or nothing. Okay. So now we have another one called promise.race. And I've been trying to think of a real life situation where you'd want to use promise.race, and I can't really come up with one. But what promise.race does is it will return when the first promise is resolved. So much like the other one, promise.race is a method that accepts an array or some iterable filled with promises, and we can call .then on it. But instead of getting back an array of results, we're literally going to get back the very first result. If one of the promises resolves after 100 milliseconds, the other ones all take longer, you're going to get back that very first result.
Would an analogy be those who pay more for one-day shipping or something like that, when you're delivering to them quicker than someone who just regular shipping, they don't pay, it gets shipped with the rest of the products in 35 days?
If I could paraphrase for Victoria, one of the Vancouver students suggested, and hang on, Lloyd, I'll get to your question in a second. One of the Vancouver students suggested an analogy where promise.race might be more like paying for express shipping over paying for ground. And it kind of doesn't work in the fact that that analogy doesn't really work in the fact that you would still expect all the rest of the ground packages to be delivered. But the ground packages would not get delivered with promise.race. As soon as that first package got delivered, that's it. All the rest are done. Okay, you're not going to get access to those things. It literally just comes back with the very first value or the very first error. Okay, so we can do something with our first result. Console log. I am the first. Promise to resolve. And then first result. Okay, Lloyd. Couldn't you use promise.race to access multiple servers with the same information and see which returns first? You could do that. Let's say you're dealing with an app that deals with stock values. And you've got various different online APIs that you can call to get the stock prices at any given time. And you just send out a request to 3 of them, or 5 of them, or 10 of them. And the very first one that comes back, you just consume that. So that would be a use for promise.race. Other than that, I can't really think of anything. If we get some time, we'll set up our own race, and then, I mean, you could bet on them, see which one resolves first. That's about it. Any questions about promise.all or promise.race? I want to show you, before we demo that, I want to get to how to create our own promises. And then we can actually demonstrate promise.all and promise.race. But I don't want to jump ahead. So any questions about the theory behind promise.all and promise.race? No? We're good? Awesome. And hopefully you can see that promise.all, this is actually something that you will utilize in your professional lives if you become a JS developer. Okay? Other languages do have the concept of promises. Some of them call them promises, some of them call them futures, stuff like that. I have included a link to the Wikipedia article that talks about all the different ways that they can be referred to. Okay? It all talks about, it essentially boils down to some deferred future value. Okay? So let's move on to our very last thing, creating our own promises. So has anyone ever had to create their own errors? Anybody? Has anyone ever? Yes. How did you create that error? The new constructor, right? So you did something like, let's get some JS syntax highlighting. You'd say new error and then pass it some kind of message like, oops, something went wrong. And what does this do? This creates a new object. Anytime you see new, it precedes a constructor function that will create an object for you. And it returns an object. So we can say const error equals new error. And then we could do something like throw error. Or we could do, if we were inside of a callback, we could say callback error, right? If we were using error first callbacks, we'd say let's call the callback with our new error that we've created. Does that make sense to everybody? Has anyone seen this syntax before? Cool. So we can do the same kind of thing. I'll just leave that up for a second. We can do the same thing with our promises. We can say, I have a new promise. So new promise. And this is a function that will return a new promise. But unlike error, which takes a string and creates an error object around that, new promise actually takes a callback function. And it comes with 2 arguments that get passed to this callback function. These arguments are resolve and reject. And these are functions. This callback function that we're putting in here is actually a higher order function that accepts 2 other functions that get passed into it. Hopefully that wasn't too many of the word function in a row. Okay? And you can probably guess if there is an error. So inside of here, we would perform some kind of operation, right? We're going to retrieve records from a database. We're going to query an API, something that takes time, okay? So we're going to perform some kind of operation. If there is an error, we're going to call the reject callback function with the error. So we're going to reject with an error. If the promise resolves, so in other words, you got your data back, everything was fine, there was no error, you would call resolve with the data. And we access this resolve maps to .then, okay? And reject maps to .catch. Okay, this is how we get it back out again. So this is what the simplest form of a brand new promise would look like. We're going to perform some kind of operation, some kind of asynchronous operation that will either resolve or reject, okay? And we are immediately returned that promise object. So we could do something like promises dot push my promise, right? We could store them in an array. We could call promise.all on them. Or we could say my promise dot then and do something with that data that came back. And we call dot catch and do something with that error, right? So you can see how this promise constructor actually gives us back a promise that we can consume. Like I said, you're not going to do this very often. More than likely, you're going to get your promises from some other library. But I think it's helpful in kind of demonstrating these things, showing you how you can create your own promises if you need to. Okay? Any questions about that before we get into, we actually do some promise.all and promise.race? Okay. So let's touch new file. We're going to touch promise all. And while I'm here, we're going to touch promise race.js. Awesome. So let's get into promise.all. So the first thing we need to do is we need to create a bunch of promises. Okay? How do we do that? With the new promise constructor, which takes a callback, which accepts resolve and reject, right? And then we're going to go down here, and we are simply going to call resolve with result of promise 1. Okay? So we're just going to say this is a nice operation. We know this isn't going to throw any errors. So we're simply going to resolve, and what's our data going to be? It's just a simple string. So imagine that we did something more complex and we returned something more complex, but for right now, we're just returning a simple string. Okay? So let's do this a couple of times so that we have a bunch of them. Change this to 2, promise.2, 3. There we go. Okay, so what's contained inside of all of these promises? Well, what do we do as developers and problem solvers when we want to see what's inside of a promise? Console log, right? So what's going to happen when we run this code? Node promise all. Well, we got back, there was a brief flash there, but it's actually resolving so quickly that we're actually getting the resolved thing back. So what if we purposefully, is everyone familiar with set timeout? What does set timeout do? It delays the calling of a function X number of milliseconds, right? So it takes a callback, and then it delays some X number of milliseconds. So let's say after 5,000 seconds. So set timeout will wait, and then after 5,000 milliseconds, 5 seconds, it's going to put this resolve onto the stack, okay? That event loop is going to wait for 5 seconds, and then it's going to go, oh, hey, you want me to process this now. Okay, so before, when we were running this, we saw we were getting the result of promise 1. Now, once we're in this, look at that, pending. And then after 5 seconds, the application actually ends because we didn't try to console log it again, right? But you can see that it's in the pending state. Whereas this one was executing so quickly that it never even hit that pending state because it was just, oh, you're just returning a string, here's the result. So the promise was actually a string there. It came back. So there we get to see it in its pending state. Okay. Does this make some sense? Anything? Okay, cool. Okay, so let's get back to where we were. I'm not going to wrap the other ones in this set timeout because I want to demonstrate. Actually, let's comment this out for right now so we can see what's going to happen. Okay, so let's push these all into an array. So const promises equals promise 1, promise 2, and promise 3. Cool. How do we get all those promises back? Promise.all, passing it our promises, right? Then we call .then, which gets an array of results. We're going to assume that none of these are going to fail, so I'm not going to worry about a .catch right now. And then let's console log the array of results, and I'll just call .join with a comma in between. Does that make sense? It's just an array of results. We're going to join them together and separate them with commas. Okay. So what do we expect to see when we run this code? What do we expect this console log to output? A series of strings, right? We should see result of promise 1, result of promise 2, result of promise 3. Let's run it and see what we get back. Node promise all and result of promise 1, result of promise 2, result of promise 3. Let's actually get rid of, let me just actually console log the array of results so you can see that it is actually an array. There we go. And as promised, sorry, didn't mean to do that. I told myself no promise puns today. We get back an array in the order of the original promises, right? Originally it was promise 1, promise 2, promise 3, and I can demonstrate that by changing these two around. So we're going to call promise 2, promise 3, promise 1, and then promise 3. So when we run this, we get promise 2, promise 1, promise 3. This, if you think about it, this has to be the way that it is. Because what if one of these was making a request for weather results, and one of them was making a request to get plane launch times, and one of them was doing something else, maybe another part of your itinerary or something. Well, when you got that back, you wouldn't want to be like, where in the array would the weather forecast data be, right? You need to know where that's going to be. You need to know what index it is, so it's guaranteed to come back in this order, okay? Because it really could not work in any other way, okay? So that is promise.all. And I want to show you, remember when we said promise.all will wait? So if we set up this first one with a 5-second delay, what's going to happen? Do you think that promise 2 and promise 3 are going to come back and then promise 1 will come back? Or what do you think is going to happen? It's going to wait. Let's clear this so we can get a little closer up. There we go. 5 seconds. It seems like a lot longer while you're staring at the screen, but 5 seconds, and then we got our array. Because these two came back immediately, and this one didn't come back until 5 seconds had elapsed. Okay? So there's our promise.all. Any questions about that? Any comments? This is fantastic. Can't wait for this to end so you can dig into the curriculum and get your own promises going. Awesome. Let's do a race. Okay, so we can steal, well, we can steal most of this. Let's do promise.race. And we'll change this to promise.race. And instead, it's going to get back, like I said, the first result, the first one to arrive. And we will console log first result. So in its current condition, what do we expect the first result to be? Never 1. Excellent answer. Never 1. Let's find out. Let's run this race. Node, promise, race. Result of promise 2. There we go. And it has resolved. I want to make it clear, because even though the console is hanging here, I want to make it clear that this fired. The dot then fired. What we're actually waiting on here is for the set timeout to complete, because that's on the global object, so that's going to run anyway. You wouldn't notice it if you had a web server which is continuously running. You would never notice that it was sitting there, but it's actually waiting for this set timeout to resolve. Okay, that's the only reason why we're sitting here staring at the console until it finally gives control back. Okay, but we see that it's promise 2, and it'll probably be promise 2 every time. But that's not my definition of a race. Why would anyone race if they knew who the winner was going to be every time, right? So let's change this up a bit. Math.floor, math.random. Has anyone created random numbers? Yes? Yeah. Cool. Let's create some random numbers. Okay, result of promise 2 and result of promise 3. Okay, so math.floor just rounds down. Okay, so we wrap that. Math.random will generate a number between 0 and 0.999999999, right? So we're going to multiply that by 5,000. So it'll give us some number between 0 and almost 5,000. And then we're going to call math.floor to round it down. So presumably our maximum wait time would be 4,999 milliseconds. Okay? Yes? Okay, so the question for Victoria is, if we had more than just incredibly simple examples, if we had a real-life example, would promise.race send them all off at the same time or sequentially, is essentially? Well, we like to think about it as at the same time. But JavaScript is asynchronous by nature, right? Or sorry, synchronous by nature. So it runs everything one line of code after the other. So it will actually dispatch promise 2, then promise 1, then promise 3, but they'll be microseconds apart. So for all intents and purposes, they all start at the same time, okay? But literally, behind the scenes, they'll fire sequentially, okay? But hopefully that millisecond thing doesn't really matter. Okay, so now we've reached a point where we can start placing bets, right? This is my other sideline. Perfect. Okay, so now we run promise race, okay? And result of promise 1. And then it's got to wait for all the other things to, and result of promise 1. But you notice that we had to wait a different amount of time. Maybe I'll shorten these so we're not sitting here staring at the screen for so long. There we go. And result of promise 3. Yay, something different. Ooh, result of promise 3 again. Result of promise 2. See, we could put 10 of these in and name them horses or something, and then we've got a game. It's just that simple. Right.
Because it approximates 3 seconds and not actually run through.
Oh, like why are we seeing different ones come back at a different time? It's because each one of them has a different timeout. Each one of them is waiting for somewhere between 0 and 2,999 milliseconds. Somewhere in between there is when it's going to resolve. So that's all we're waiting for, is just which one's going to come back first. So we had 1, 1, 3, 2, and then 1 again. Okay? Any questions about our contrived race example here? Are we cool? 1140. So let's move on. So this is kind of, and I want to kind of talk to your simple promises example. Because remember how I showed you at the beginning that we would run a file, the survey file, with callbacks, and then we run the file with promises, and what did we arrive at from a client perspective? The client doesn't care, right? As far as they're concerned, it's exactly the same. So I want to separate out the idea of a simple promise, because we don't actually have simple promises. It's either a promise or it's not a promise, right? It's either a promise object or it's not. There is no real concept of, all a promise is it waits for some operation to complete, and then it calls resolve or reject. That's it. So the way that you consume them, even if you said, well, this is a far more complex operation, we're going to be writing to the database, we're going to be trying to authenticate a user, we're trying to do all kinds of different stuff. The way that you consume it is you call .then on it. Doesn't matter what's going on inside this promise, you call .then, everybody's happy. Complex example, simple example, you call .then on them. And that's it. That's kind of the secret to promises. It gives us one interface for handling all this stuff. Okay? Did that kind of answer your question? Or talk about the simple thing? Sweet. Okay. So we have 19 minutes left. Oh, is there a way to know what the order that they will all return? Just like a horse race, you know the winner, but you also know where the other horse is placed. Ah, see, there's you shot a hole in my horse analogy. No. There's absolutely no way to know what happened to the rest of the results. They won't bother to return. The way that race works is the first one gets across the finish line, and then who cares about all the rest? Yes?
What happens if the first one finishes before a later one makes an error?
Ah, okay. Let's do this. Let's try. We are going to do reject. Promise to, so we'll just say promise to error. Okay, so now we're sitting in a completely random place. These two will resolve after somewhere between 0 and 3 seconds, and this one will throw after somewhere between 0 and 3 seconds. And just to make sure that we can do this, let's add a catch, which accepts the error. And so that we can see it, let's console.error the error. Okay, so we're going to handle that should they reject. Now let's see what happens. Hopefully we don't have to run this too many times. Promise to error came back first. Promise to error once again. Result of promise 3. Do you see an error? Excellent question. Result of promise 1, no error. So it's literally the very first thing to come across the finish line. Either it's a resolved or rejected promise, and that's where we end up. See, we got promise to error again. But it doesn't matter at all what the rest of the things in the race are doing. Once the first one crosses the finish line, they might as well have never been called. Okay? It's not going to crash your program. What's that? Why is that? Well, yes?
And you ruin the whole thing. The whole thing gets ruined because one of them goes really early and then it goes out.
Well, that would be very annoying in a promise.all because it would mean that you wouldn't get back any of those other results. You'd just get back the one error, right? But in a promise.race, you're literally racing them. You said go and come back. So maybe some of them are going to error out. One of the most common errors is a timeout error. You make a request to a server and it sits and it waits and it waits and it waits until it hits its timeout and it says, I didn't get a response back. But hopefully by that time, something else has come back. That's why we're racing them, right? So there was another question. Yes? If we change this time, if we change this to something like a really long time, shorter time, then we would never get anything but the error, more than likely, unless one of these resolved to 0 milliseconds, right? It would have to try and beat this. But odds are, if I was going to place a bet on it, I'd say that promise 2 is going to error out every single time, except for those rare instances when this comes back at something less than 50 milliseconds. Okay? Cool. So let's set this back to 3000. There we go. So this is all well and good. But what if we wanted to rewrite something in JavaScript that natively takes a callback? We'll just do this as a little something extra for the last 15 minutes. And feel free to, the official introduction to promises is over, so if you have questions, feel free to shout them out. Otherwise, I'm going to refactor timeout. and we're going to call it timeout promise. Okay? So we already have this concept of a set timeout. Actually, I'm going to change that to set timeout promise .js. There we go. Okay. Where are we? Set timeout promise? Awesome. Okay, so we have this concept of a set timeout. How do we do it? Well, we've already seen the example. It takes a callback, and then it waits some number of milliseconds, right? Could be 5,000, 500, 2,000, whatever it is, right? So let's take this idea and let's refactor it to use a promise. So the first thing I want is I want to create a, actually I want to set it equal to a constant. So we're going to call this set timeout promise equals a function, okay? And what is the key thing that set timeout does for us? Unlike for each or something like that, the callback doesn't take any arguments, does it? It just executes the callback after a certain amount of time. So what do we want to replicate with ours? What is the one piece of information that's key about set timeout? It's the wait time, right? Okay. So let's have our function accept some time to wait. And then inside, we're going to say return. Yes, let's go with return new promise. How do we create a new promise? It accepts a callback with resolve and reject. And then inside of here, we're going to literally wrap set timeout. So we know the second argument to set timeout is going to be how long to wait, right? Imagine this is passed in and this is 5,000. Well, then we're going to pass in 5,000. What are we going to pass as the argument to be invoked? Because this is the way set timeout works. You pass it a function, it waits this much time, and then it invokes this function, right? That's how set timeout works. So what do we have available to us within this function that we could pass? What does a promise do when I can't even use the word. What does the promise do when it is fulfilled? We resolve, right? So we can actually just pass resolve. So in other words, set timeout will call resolve. This is the same as we were doing in our promise.race. It will resolve, but it will resolve after we wait for it, okay? So if we are going to consume this here, we would call set timeout promise, give it some kind of wait time, like let's say 4,000 milliseconds. We know that it returns a promise. And what can we do with a promise object? .then. And inside of here, we say console log. We're not passing anything. Like resolve is not passing any data to us, so we don't have to accept a data argument, right? And we're just going to console log set timeout promise has completed. And that's it. What happens when we run this code? Let's clear this, and we'll do set timeout promise. 1, 2, 3, 4. Set timeout promise is completed. Okay. So we've managed to refactor set timeout to use promises instead. Okay. One thing to note about this is we could have said const my promise equals new promise and then returned my promise, right? Or, yes?
If we don't pass a valid wait thing for set timeout.
Ooh, interesting thought. We'll check that out in just 1 second. So we could have set this equal to a variable, right? Because we know that it's returning an object. But then we have to come up, remember that one of the first Google searches we did? Naming things is hard. Then you have to come up with a name for it. You have to put it into memory. Then you have to return it later. If you're not actually going to manipulate it in some way, just do an inline return. Okay? We'll just return that new promise. Okay, so we want to consume this. Set timeout promise, and we're going to pass a string. And then we're going to say dot then console log. Everything is fine. Dot catch. Let's see if we actually get an error. Console dot error, error. Okay, so we're trying to pass an invalid argument into our function. Let's see what's going to happen. Ooh, everything is fine. Everything is fine. But you'll notice it's not waiting. So what happens if we pass an invalid argument to set timeout? So if we do this, we should have to wait for 5 seconds, right? For set timeout to fire. Set timeout fired. Perfect. Now what happens if we pass something that's not good? What happens? Oh, that was clear. There we go. So we'll see that the default behavior for set timeout is if you don't pass a valid number, it just executes immediately. It probably just interprets this as 0. Just do this thing right now. Okay? We learned something new today. Oh, I did. Well, it doesn't. You can't catch something that was never thrown. Aha! We got deep and philosophical today. This doesn't actually error out. Our code just continues to run because set timeout, the creators of set timeout, handled that internally. And they just said, if you didn't pass a valid number, then just execute it immediately. Yes? Well, if we pass in undefined, there we go. Let's run this again. Set timeout fired. So they've thought of that. Yes? You could, absolutely, if you wanted to. And you could, let's do that instead. Let's go back to our original code that we had. So since we're writing this, let's say that this is disruptive. Let's say we're making an API request and we need to have a username or a user ID, and it has to be a valid user ID. It can't just be whatever somebody decided to throw in there. We can say if wait is, how would we, is number? How do we check to see if something's a number in JavaScript? Sorry? Type of? Okay. Let's try type of. Let's quickly do that in here. Node, const num equals 9, type of num gives us back number. Perfect. Get out of there. So, if type of wait does not equal number, reject with you must supply a valid number. Okay, so now we're going to pass in oops. So do we think we're going to see everything is fine? Or do we think we're going to console log the error? Let's find out. Aha! Reject is not defined. Why is reject not defined? Oh, because we're not inside of there. We would have to X, put this inside of here. There we go. Let's do that again. Clear? You must supply a valid number. So we were able to handle that ourselves internally. Okay, so we now have our set timeout promise. It has the same functionality as the regular set timeout. And we now have this new capability of rejecting things with an error message if you didn't actually pass in a number to it. Okay? So what can we do with this now? What did we learn about on Monday? We can export this to consume it in our code somewhere else. Okay? So let's touch timeout compare.js. There we go. And we'll open up timeout compare. And we'll set up our two. So we'll say const time set timeout promise equals require set timeout promise. So now we have access to that function. So we're going to set a timeout, just the old-fashioned way. That will fire after 2,000 milliseconds. And we'll console log vanilla, for lack of a better term, timeout fired. And then we'll utilize our set timeout promise, pass it in, let's say 3,000 milliseconds, and call .then on it. And we're going to console.log set timeout promise fired. Okay? Seems good. Node timeout compare. Vanilla timeout fired. Set timeout promise fired. Yes? So the question for Victoria is it possible to create a higher order function, and it's in a function that accepts a function, but instead of doing something else, it wraps that function in a promise? And yes, yeah, you could absolutely do that because you can pass these things around, and at the end of the day, a promise is just an object. So you could wrap that inside, and you just say resolve. You'd more than likely do something inside of it that you'd be like resolve the callback. And so it's a promise that when it resolves, it calls the callback function that you passed in. Okay? So you can see how, once again, we can consume this code. This is kind of, I think, the big takeaway from today, hopefully, is we can consume this code without caring at all about the underlying structure, without caring how it is implemented. We simply know the interface that we need to use to access this code and make it do what we want it to do, right? We can either do the classic set timeout, where we say, here's a callback and execute it after this much time, or we can call our new set timeout promise, give it an argument of a wait time, and then call .then on it to see it resolve, okay? But this is kind of how you'll be utilizing promises now, is when you read the documentation and it says X function returns a promise, you'll say, oh, I know what to do with that. I call .then on it, and I call .catch to catch any errors. One other thing that we can quickly demonstrate, 11:58, we have 2 more minutes, is you can continue calling .then on something. Even if it doesn't, if we look back at our, actually we can look at our survey promise, you'll see that every single time I was returning a new promise, right? We were returning a promise and then calling .then. So what happens if we call .then on something that does not return a promise? What do we expect to see from this? Should I toss in a .catch? Because what if this was going to error out? Okay, so what do we think this code is going to do? We did not return a promise from this .then. What's going to happen with this one? Sorry? No. Nothing. One of the guesses from here is nothing. Any other guesses? You think it's going to chain and also return? Okay. Any votes for erroring out? Or did I waste my time attaching that .catch onto there? It will do that. Are we just going to go with the vague that? Perfect. It will do, something's going to happen when I press enter. Is that surprising to anybody? So remember, one of the things I said is that a promise returns immediately, right? And setting something up with .then returns immediately. So this one returns and this one returns. So essentially we've said perform these 2 operations after 3,000 milliseconds have elapsed. And that's why we see both of them fire at exactly the same time. Boom. They both go to the console, no errors. Which begs the question, why on earth would you call .then on something that wasn't a promise? I don't know. I just wanted to show you that you could do it. Because if you were going to just do this, like console log something, why would you not just do it all in the one callback? Why would you chain it out to another callback? But you can, if you're so inclined. And they will just all execute. Consider all of these as saying, when this promise resolves, execute all of these .thens that are attached to it. Okay? Any other questions before we wrap up and you can get on with your day? 12:01. What do you think about promises? Worse, better than callbacks? Super hazy? So, like I said, the rest of the curriculum will be more promise focused. So anytime that you're given the opportunity to say either a callback or a promise, we're going to lean towards promises, because in the professional world, you'll see a lot more promises, and it's usually just because of the syntax. It's a lot easier to read and to reason about. One other little thing, just kind of a reminder, throughout this curriculum, we intentionally do not teach async await. You can research that on your own, if that's fine, but I think it makes it even easier to consume promises, but if you don't actually know, if you haven't wrapped your mind around what promises are, then it might seem like too much magic, and you won't actually get the knowledge that you need of working with promises, calling .then, calling .catch. Okay, so if you see documentation that uses async await, or you come across something else, we intentionally don't teach it at Lighthouse, because we want you to really dive into what is a promise and what happens with it. And async await doesn't really allow you to come to terms with that. Okay? Cool. Anything else before I let you go? Awesome. Thank you very much for your time, and I wish you luck in your promise journey. Thank you. Thanks, Victoria.